Okay, determine the cubic function that has zeros at -2, 3, and 4, and if f of 5 is 28. Well, if it's a cubic function, the degree is going to be 3, right? And we want to look at a cubic function in factor form. Now, if we're looking at a cubic function in factor form, we want to think about in the form of ax minus r, x minus s times x minus t, where r, s, and t are roots or x-intercepts. Now you can imagine here that these are all factors with an order of 1, right? That means it passes through these points, right? The total orders have to add up to 3. Does that make sense? So in this case, a potential way we can write this, ax plus 2, x minus 3, and x minus 4, right? So you just, you can let r equal -2, s equal 3, and t equal 4 if you plug it in. The only one that changes values here is the -2, because you'll have x minus minus 2 when you write it out, and then you get x plus 2. That's why you can think about it as changing the sign of it, if anything. Now, this equation represents the equation for the family of functions. Okay, so this is the equation of the family of functions. And a family of functions is basically a series of functions or polynomial functions that have the same degree and same x-intercepts, right? So same degree and same x-intercepts. The only thing that they really differ with is this a value. And the a here is your vertical modification factor. Okay, your vertical modification factor can change, right? For instance, if a is greater than, first of all, if a is less than 0, there is a vertical reflection, right? So you can kind of recall this when you guys study transformations, right? When a is greater than 0 but less than 1, if a is a fraction, we have a vertical shrink, right? So a vertical reflection, first of all, means that, this is your original graph, right? Whoops. Wow. Sorry about that. Right, this is your original graph, right? Your reflection here is basically gonna look something like this. Right, but you'd have the same x-intercept. I didn't draw this too well, but I think you guys get the idea. Right, you get the same x-intercepts, and then this would be negative f of x, and then this would be f of x. Now I didn't draw the cubic function in this scenario, I just drew a quartic function, but you get the idea. You would imply the same notion, right? A vertical shrink would mean that if this is your original function, and I'm just going to use a different function to show that, if this is a quadratic, as your original function, right, a vertical shrink here would basically mean this, right, a f of x, and a here would be greater than 0 but less than 1. And notice I'm just looking at the absolute value of a, right? So that's what a vertical shrink would look like, right? And in the other scenario, if a is greater than 1, we have a vertical stretch. Okay, so I think I'll stick with using a quadratic to show you guys an example. But if this is, maybe I'll just do it out here. But if this is your quadratic function, f of x, the vertical stretch of that function would kind of look something like this. Right, you still have the same x-intercepts, but now the graph itself looks longer and narrower, right? So these are just some things to keep in mind. We want to figure out what this a value is, and we know that we're given a point, f of 5 is 28. Well, that tells us that 5 and 28 lies on the graph. Remember that f of 5 basically means y when x is 5. Okay, y when x is 5 is 28, so the point is 5 and 28. So what you want to do now is you want to plug this in, right, into your function. So if I do f of 5, you basically get a times 5 plus 2, 5 minus 3, 5 minus 4, which is a times 7 times 2 times 1, which is 14a. And we know f of 5 is equal to 28. So 14a is 28. And this tells us that 14a is 28. If I divide this by 14, a is equal to 2. Okay, so therefore, right, f of x, the equation here is 2x plus 2, x minus 3 times x minus 4. So that is your equation of your function.